I will explain today the equation of motion which was given by the Newton to determine the velocity, your distance, and your acceleration of of an object which travel in a constant acceleration or time. So these are the three equations which was given by the Newton law, where v is your final velocity, a is your acceleration, u is your initial velocity, t is your time taken by the an object, and s is your velocity. So let's firstly introduce the graph, what the graph means. Your x-axis was taken by the time, and your velocity was given by the y-axis. So let's ab was an object or a distance traveled by the object at a particular rate of change of velocity at a particular time. Let's draw a line toward the x-axis. This is your line toward the x-axis. So this is your b is your final position of an object. A is your initial point, and b is your final point. So let this considered as a v, your final velocity. This is your final velocity because we consider x-axis as a time. So a is your initial, v is your final velocity. Let's again we draw, let's this point consider as a d, we consider as d. So let's consider also we draw a perpendicular line toward the y-axis, which consider that this line is your initial velocity or your initial point or initial velocity where an object did not start its journey. It is about to start. So let's consider as u because it is your initial velocity. Let's ab, let's this point consider as a b, and this point consider as a o. So let's begin for the first equation of motion. We assume like let u be your initial velocity, u, and v is your final velocity considered as a v, and draw a perpendicular line and x-axis, which I have already done above the graph. So you can write this and you got half marks in this written form. So let's consider as a bd is a distance or a velocity traveled by the object. So we know that o is a point, so vd is nothing but the sum. Vd is nothing but the sum of bo. Bo is a certain distance and od is a certain distance. So we can write like bd is equals to bo plus od. This how we consider as bo and od. We know that vd is your final point or a final velocity that the object travel. So let's consider vd as v. So vd we consider v, and your so after that od, and nothing but od is an rectangular. So you have already see that aoco is like a rectangle. So whatever the length of the opposite side is, we know the property of rectangle that opposite sides are always equal. So ac is nothing but od. So ac and ods are equal, so we consider as u. So after consider as u, we can write that od equals to u and bd equals to v. So we left out by the bo, and bo is nothing but the height of the graph or something that we have to find. So how we can find is by the method of slope. Taking slope of the graph, which can give the acceleration, because the velocity and the time graph slope given by the was given the slope or the acceleration, or we can simply tell that the slope of the graph velocity by time is given by the is given the acceleration. So acceleration is nothing but we can find the acceleration or the slope. We can find the slope equals to height by base. So a is nothing but the height bo or base ao. Bo is nothing, we have to find bo is your x. So ao is nothing but the time traveled by the object at the initial to final position. So ao is nothing but the time. So ao is time, A is nothing but the slope is nothing but the acceleration, because it is a rate of change of velocity. So A is considered, so A, and AO is T. So whenever the T goes in your left hand side, we consider AT BO equals to AT. So we, by getting this point, we can put this equation in equation number 1. Then we consider as V equals to U plus AT. This is the first equation of motion. Let's begin for the second equation of motion. So whatever the graph we have given, like whatever the graph is given, like your graph is given like this, your graph is given like this, the area, the distance is nothing but the area under the graph. So the distance is nothing but the area under the graph. So we can find the area or the distance traveled by the object is CABDC. So if the travel is AB, the area under this curve is nothing but the distance of the object which he traveled. So an object they travel, or he, sorry, for my small mistakes. So let's, so distance equals to area, the area under the graph. So we can find the distance equals to area under the graph ABDC. So there are two figures, geometrical figures under this graph. Is one is your triangle and one is your rectangle. So area, we can write the distance equals to area of triangle plus area of rectangle. So area of triangle, we have already known that half base into height, and area of rectangle is length into breadth. So distance is nothing but the base is your AO and height is your BO, plus length is your AO into breadth is your AC. So we know that AO is nothing but the time travel by the object. So we can consider AO by T, and we already find that BO is nothing but your AT. We already find in your first equation of motion. So BO equals to AT. We can write that BO equals to AT and AO equals to T, and your AC is nothing but your initial velocity. So after multiplying both the this equation is nothing but A, and there is 2T. So we can consider that T square and plus U plus AT. By arrangement of this equation, we can find that S is nothing but UT plus half AT squared. By this, we can get the distance traveled by the object by this equation of motion. And your last derivation of this equation of motion is your distance. So there is one more figure, your trapezium figure. When we cut this trapezium figure, look at this is a type of a trapezium which we can see. By rotating this paper, we can see that this is a type of geometrical figure which we consider as a trapezium. So we consider this whole as, now we consider this whole as a trapezium. So distance equals to area under the graph. Area under the graph is nothing but the area which we consider as area of trapezium. So we know that the area of trapezium is here half some parallel side. Your parallel side is your this side, this both are the parallel, and this CD is your height. So your sum of the parallel side is nothing but your half V plus T into T. Height, because CD is your height, so we consider T is a time. So by this we can help from the first equation of motion. We know that the first equation of motion is V minus U plus AT. When we shift this U to left hand side, we consider we get that V minus U equals to AT. When the A and T is multiplying, when we shift this A towards the left hand side, we got V minus T by A equals to T. Why we are doing this? Because we have to put value of T in this value, because sometimes we did not get the constant time. in any motion, so that's why we use this value where we have to remove this t. So putting the value of t in equation number 1, we get that s equals to half v plus t into v minus u by a, and 2a is multiplying, so we can shift this 2a towards the left hand side, 2sa. So v plus u, v minus u is multiplying. When we multiply or using the identity a square minus b square equals to a plus b minus a minus b, so using this identity we can put that v square minus u square equals to 2as. This is nothing but the velocity. We can find any object, its acceleration, initial velocity, final velocity, and the distance without knowing the time. So thank you for all. Hope you liked my video, and